Welcome to the shop course on welding fundamentals and key terms. Now let's look at how we describe a groove weld. Many of the same terms transfer right over from fillet welds. For example, the top of the weld is called the weld face or the weld cap, and the bottom or the back side of the weld, the first pass that we put in, is called the weld root or the root side of the weld. The term weld toe still describes the intersection where the top of the weld intersects with the base metal, but the throat of a groove weld is slightly different due to the different configuration from a fillet weld. Here you can see that the weld throat is effectively measured by the distance from the root to the face or the cap. It just looks a little bit different, being that the weld geometry is slightly different in shape. Another aspect of a groove weld is called the weld reinforcement height, and that is the distance from the base metal up to the top of the weld cap. In addition to the weld reinforcement, we also have to talk about the root reinforcement height, which is, in the case of a complete joint penetration weld, the distance that a weld penetrates beyond the base metal. Now, like a fillet weld, a groove weld is perfectly acceptable when the reinforcement is completely flat, not down below the surface of the base material. However, if we have a little bit of reinforcement and a little bit of root reinforcement, it helps to increase the area of the weld, which makes it a stronger area because there's more mass there. However, like anything, you can have too much of a good thing. Most codes and a good rule of thumb is to keep that reinforcement at 1/8 of an inch or less so that you don't create any additional stress risers that might render the weld or the assembly unfit for service. Complete joint penetration or CJP groove welds can be done as an open root or as a weld with backing. Open root welds are more difficult because there's less material there and nothing really to support the root. Open root CJP welds often require back gouging and back welding to remove any material that could have been exposed to the atmosphere. And then when you put the weld in on the back side, you're ensuring that there's solid metal there. CJP welds are quite commonly used for pipe and tubing, and those applications often use an inert or mostly inert backing gas or a purge so that it protects the weld on the backside. CJP welds made with backing provide additional support to the root pass. We have material there or some type of support that's going to prevent us from burning through. So CJP welds with backing are often much easier to accomplish than an open root configuration. Backing material could be permanent or removable. In some cases, a backing bar or a backing weld might be used and permanently become part of the welded configuration or the welded structure. On the other hand, you can also use materials like copper, stainless, and even ceramic to support the weld and displace or block the atmosphere from getting at the liquid metal on the backside of the root. Some backup systems use inert gas and have ports that actually provide a continuous flow of gas to provide shielding, especially in aerospace and aircraft where weld quality and integrity is of utmost importance. Now let's talk about groove types and different ways we can prep the weld edge. Well, the most simple form of a groove weld is simply a square groove, where we take the squared off edges of plates or sheet and butt them right up together and go ahead and weld either from the top side or the bottom side, depending on the weld quality requirements and depth of penetration. Typically, these are the least expensive because they require the least amount of prep, but thicker materials require more edge prep. So what we're going to see in most cases for arc welding processes is a full penetration groove weld is going to be limited in thickness unless we're able to flip the plate over to the back side. So we typically try to see square groove welds done on materials 1/8 of an inch and less, unless we're using a high-powered process like submerged arc welding or even gas metal arc welding with the right weld procedure parameters. Next is a single bevel groove, where one side of the groove weld is beveled at an angle to allow better access to the root or penetration side of the weld. If the top and bottom side of one member is beveled, we call that a double bevel weld. And if both edges of a groove are beveled, we call that a single V-groove weld. And as you might guess, if the top and bottom side are both V-grooves, we call that a double V-groove weld. J-bevel and U-groove options can also be used in these same configurations. However, they're more expensive to produce because we can't simply grind on a J-bevel to create a U-groove. Oftentimes these need to be machined. So the benefit is certain materials such as aluminum perform much better when a J-bevel or U-groove is used as opposed to a standard V-groove, which is more common in steel and stainless steel. Other common groove joints include the flare joint configurations. Both the flare bevel and the flare groove involve welding radiused or rounded objects to one another. Now let's talk about the terms used to describe various groove weld features. The first important feature to talk about is the root opening, or the space between two components that we're putting together. The root opening is critical because if a root opening is too wide, it can be difficult to weld without burning through. And at the same time, if the root opening is too narrow, it can be very, very difficult to achieve adequate penetration through the root. The next component of the root area is called the root face. This could also be called the bevel face or the groove face, and the slang term is called the land. And what this is a prepared groove face in the area of the root. And what it provides is greater cross-sectional area in the area of the root to prevent you from burning through. So if you're running a groove weld and you tend to be over-penetrating or making holes in the root, you might want to try a root face or a land to give yourself a little bit of more cross-sectional area at the root interface, and that will allow more material to stack up before it melts off and causes burn through. The next feature of a groove weld is the bevel angle. And this is the angle that we've ground off from 90 degrees. And the combination of both plate bevels forms the included angle.